Hey, welcome back, everybody. We're still looking at our same lesson that we've been on the last couple days, lesson 8.5. There's just so much in here. And if I'm being perfectly honest, I haven't really ever taught this to Algebra 1 before, and I really was unsure if I wanted to teach this to you guys, and I thought I might be able to just let it go till next year, or actually in 2 years when you do Algebra 2, but man, people are doing so well on the assignments, and I've got confidence in everyone that even though this may not be really a topic that I had to teach you this year, it's in our book, and everyone seems to be, at least the people that are doing the assignments, seem to be doing really well. So I'm confident you all can handle it, and I will keep going through this because it looks like we're doing pretty well and we're understanding it. So I showed you a little bit of this yesterday, but not very much. What would a graph of a cubic function look like, right? This is not going to be a parabola. This is going to have more of a curve to it like that. And so this is how we're going to graph a cubic function. And once again, this is not really an Algebra 1 topic that I know of anyway, at least in Missouri, but I'll show it to you anyway. Okay, I've got some of these on the left that have a letter Y. I've got some of them that say f of x. I've got one that says g of x. Don't let any of that bother you. It's all kind of the same thing. That should not affect your thinking. What we are going to look at is this very first one right here. And what we want to look at is where are the x-intercepts, right? Where are the zeros? And so I could even replace this letter Y with a 0. And then if you remember the zero product property, I could ask you, I'm going to put the first one in parentheses, what number would you put in each parentheses to make each parentheses equal 0, right? We have three things that are all being multiplied. We know the final answer is 0, so we know one of these three parentheses had to equal 0 because any time you multiply something and you get a final answer of 0, you know that one of the numbers that you multiplied, one of the factors, has to be 0. So you could just do a quick little survey and ask yourself, okay, what number would I have to substitute in for the x to make that parentheses equal 0, right? 2 times what equals 0? And that's obviously 0. So look where I'm going to put a dot. I'm going to put a dot right at 0 on the origin. That's one of the zeros, right? What number would I put right here to make this parentheses equal 0? It would have to be -3, right? Remember, I've been saying that in the last couple of videos. It's always the opposite of the way that it looks, right? If it says +3, that's actually 3 to the left. And here on this one, at the end, it says -2. That's actually 2 to the right. And the reason that it's 2 to the right is because you would have to put +2 right there to make that parentheses equal 0. 2 minus 2 would equal 0. So I know that this cubic function is going to touch the x-axis in these three places, but I don't know if it goes up and down and up like this, or maybe it goes up like this and then down. You really don't know just by looking at it. So you just can't guess, and you don't really know how tall it goes. You don't know how low it goes. It may go really high. It may just go a little bit. You don't really know the order or of the kind of the wave there, but you do know your three x-intercepts, or your three zeros. Those mean the same thing. So once you get your x-intercepts or your zeros, you need to figure out, okay, where is the graph in between here? Is it up here? Is it down here? Is it way at the bottom? Is it way at the top? Is it somewhere kind of in the middle? And the same thing in between these 2 points. And so what I would do is I would just take a little space down at the bottom, and I'd pick a point in between your x-intercepts or your zeros. So I'm going to pick -1. I could pick all -2 as well, but I'm going to pick -1 just because that is a little bit easier to deal with. And here I'm going to pick +1. And we'll just plug those in to the original problem way up here. We'll plug it into the original problem, and we'll see what we get. So if I take my original problem, and if I put -1 in the spot of all three x's, here's what it would say. The first parentheses would say 2 times -1. The second parentheses would say -1 plus 3. The third parentheses would say -1 minus 2. Sorry, I'm bleeding into my table there. And now I can just work that out. 2 times -1, that's -2 in the first parentheses. The second parentheses, -1 plus 3, that equals 2. The third parentheses, -1 minus 2, that's -3. And then I can just multiply it. -2 times +2 is -4. -4 times -3, sorry, let me move my board back a little bit, equals 12. And so I know -1 12, negative 1. Look, I only made my graph go to 10. 12 is actually way up here somewhere. Negative 1, 12 is a point on my graph. So look how high this thing goes. It goes way up here and then comes crashing down all the way down here. That thing was way higher than even I expected. All right, but I still have one more point to go, right? I haven't filled out my table for positive 1, right? This answer was for negative 1. Now I need to do the one for positive 1. So if I take positive 1 and put it in the spot of the parentheses up here, I would have 2 times 1. I would have 1 plus 3. Whoops, didn't mean to put all those dots on there. And then I would have 1 minus 2. And so 2 times 1 is 2. 1 plus 3 is 4. This is 1 minus 2. Sorry, that looked like a dot. That's 1 minus 2, which is negative 1. And then I can multiply all that together, and I can get 8 times negative 1. 8 times negative 1 is negative 8. So this would have a point of 1 and negative 8, which is way down here. And so you can see, let me flip back to red, so this kind of looks like the same graph. This graph would go crazy like this, right? And that's how you could graph a cubic function, right? Step 1, find the zeros using the parentheses, and if this isn't a parentheses, you can just put parentheses around it like I did. Find the zeros. There should be 3 of them. In most cases, I don't know if there's a way to have less than 3 or more than 3. I guess there could be more than 3. I don't know if you could have less than 3. I don't have a lot of experience with these. So find the zeros, and then make a little chart for yourself, and pick points that are in between your zeros, right? I picked negative 1 because it was in between those 2 dots. I didn't pick negative 8. I didn't pick negative 5. I picked a point in between these 2 dots, and then I picked a point in between those 2 dots, right? Okay, if you really want me to do another one, I can. I may not actually graph all of these, but I can do another one. Let's see what we've got here. Okay, the second one. This one's a little more straightforward. You have 3 parentheses that all have x minus or x plus something. And so I know that this is going to be, well, hang on, let me get this off the board. This is going to be the zeros, or the x-intercepts. This is going to be pretty easy to at least get the zeros, right? I know right here, when it says plus 1, that actually means 1 to the left. Another way, if you put a 0 right here, right, and you ask yourself, hey, what number would you put right there to make it equal 0? It would be negative 1. It would be 1 to the left. So I'm going to make this in blue so my dots, orange dots from the last one, don't confuse you. I'll get the orange dots actually off of there. That's going to be kind of confusing. And now my graph is all screwed up. I apologize. Whoa. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, I lost one. Let's do another one for negative 10. 1, 2, 3, 4. Okay. So I know one of them is going to be negative 1 because plus 1 actually means 1 to the left. Here, minus 3 actually means 3 to the right. Or another way to think about it is the number 3. If you put 3 right here in this first spot of the parentheses, 3 minus 3 would equal 0. And then the other one, plus 3, is actually going to be 3 to the left. I don't know why I copied that down again. It really didn't help me. 3 to the left. So right there. So I have a 0 at my x-intercepts are negative 1, positive 3, and negative 3. Negative 1, positive 3, negative 3. Boom, boom, boom. So I know, once again, I have a cubic function. This is going to have another wave to it. I just don't know where the wave is going to go. Remember how high the last one went? This one could also go way up there, or maybe it's way down here. I don't know. Or maybe it's down this way. I don't know how to make my little curve. And so what you need to do is pick some points that are in between the zeros you already have, the x-intercepts you already made. So like this point right here is perfect. It's right in between these 2 dots. This is negative 2. I'm definitely going to put negative 2 in there. And then I have my choice. I can pick any of these points over here. I could pick 0. I could pick 1. I could pick 2. I'm going to pick 0. And just for fun, I'm also going to pick 1. I really don't need to. But I'm going to pick 0 and 1. So if I go back up here to the original question, and I put negative 2 in the spot of the x, here's what I would have, right? I'd have negative 2 plus 1. I'd have negative 2 minus 3. And then I'd have negative 2 plus 3. Okay? And I could work that out. Sorry, my handwriting kind of got crazy there. Negative 2 plus 1, that's negative 1. Here, negative 2 minus 3 is negative 5. And then the last parentheses, negative 2 plus 3 is 1. So I could work all that out. Negative 1 times negative 5, that's 5. 5 times 1 is 5. So negative 2, 5, 1, 2, 3, 4. See how much nicer this one was? This one wasn't nearly as crazy as the last one. So I know I've got at least this part of my curve going. Now let's put 0 in there. Let me erase what I did up here in orange. Now if I put 0 in the spot of the x's, I just work it out by substituting 0 in there. So if I put 0 in here, it would say 0 plus 1. This one would say 0 minus 3. This one would say 0 plus 3. And then you can just work it out. So that would be 1 times negative 3 times positive 3. That would be negative 3 times 3. That would equal negative 9. So 0, negative 9, way down here, is another point. If I get my orange marker back, I've got at least this part of the curve. And then I also picked the number 1 just to have a third point. You really didn't need to do this. If I'm being honest with you, I could probably freehand it from here going up. But just to make it a little bit better and less of a freehand and more of an accurate graph, I'm going to put 1 in here. 1 plus 1, 1 minus 3, 1 plus 3 in each spot where the letter x is. And so that would be 2 times negative 2 times 4. And let me see, that would be, negative 16, right? Oh, so I was actually wrong. I was prepared to make this thing go back up, but really it keeps going down to like negative 16 way down here. So this thing actually kept going down, and then it started going up way over there. So I guess that did kind of make sense to make another point there. So there you have it. That's how you graph a cubic function. It's not exactly hard. It's just kind of time consuming, and it is kind of annoying sometimes to have to fill all that out. The good thing is on our computer assignments, you don't actually have to graph these on a coordinate plane like I do. You can just look at the graphs that they've made and match up the ones that are correct, or if they already have a coordinate plane on the computer for you, you can just use their coordinate plane. Now let me do, you know what, I can go ahead and do these two down here. These aren't in the right format yet. You know how these look a little different than the last two? The last two already had all those parentheses done for us. There's no parentheses on these. We need to factor these first, right? If I look at this one, do you know something in common, right? Could we divide both those numbers by 4? Sure. Do they both also have a letter x? Do both terms have a letter x? Yeah. And so what I could do is I could divide everything by 4. I could take an x away, and I can factor it like we factored a polynomial in the last chapter. 4 divided by 4 is 1. I'm not going to put a 1, but I could put it. If I take an x away, instead of having 3 x's, I only have 2. And then 36 divided by 4 is 9. And if I take an x and take it away, I don't have any x's left. And so now I have this. But wait a second. I don't think I'm done yet, am I? Isn't my parentheses still factorable? Doesn't my parentheses look like a perfect square? Right? Difference of two squares. Isn't x squared plus 9 the same thing as x plus 3 and x minus 3? Right? This is a perfect square. I know the square root of x squared. It's x times x. Negative 9, or 9 is a perfect square. I know that's 3 times negative 3. And so this right here is actually the format you need to graph this one, right? They had a couple extra tricky steps at the beginning. We had to factor it. And now that I have it factored, now I can do it like I did the last ones, right? I can look right here and say, okay, I have 3 things, 3 parts being multiplied. Those are going to be my 3 x-intercepts. What number would I put right here to make this parentheses equal 0? 4 times what equals 0? That's got to be 0. On this one, 3 plus 3 actually means 3 to the left. Right there. This one, minus 3, actually means 3 to the right. Right there. And so I have my x-intercepts. My zeros are at 0, negative 3, positive 3. Those are my zeros. Boom, boom, boom. And then I can do this one just like I did the last one, right? I can make an X and Y table. I can pick a point in between 0 and negative 3. How about we pick negative 1? I can pick a point in between here. How about I pick positive 1? And then I can plug it in just like I did on the previous question, right? And so if I take negative 1 and I plug it in, it would be way up here. It would be, 4 times negative 1. You'd have negative 1 plus 3. You'd have negative 1 minus 3. And that would be, oh man, I'm running out of space. That would be negative 4 times 2 times negative 4. And that would equal, holy cow, that's going to equal 32. And so negative 1 is going to go with 32. That's going to be way off my graph. Like it's going to be way up here. So I can barely even draw that. And then if I took positive 1 and put it in there, I'm going to write down below. That would be 4 times 1, 1 plus 3, and 1 minus 3. And that would give me, let's see, that would be 4 times negative 2. That would be negative 32. Holy cow. This thing goes way up and then it goes way down, right? And so I'm going to draw it like that, but that's like way off my graph. Okay? That one went way off my board. I apologize for that one. But you see how I had to factor it at the beginning? That's the important part. They won't always give it to you factored all the way yet. Sometimes you have to factor it. And that's what we're going to have to do here on this last one. Let me go ahead and erase this craziness off my board here. That one went way off this page. You know what, I'm just going to start from scratch if I need to. Okay, grand finale. We've got a statement, a function here that is not factored yet. Right? I don't have... That's a 5. I don't have this in parentheses yet. It's not factored, right? Do I see something in common here? Okay, they all have an x, so I can definitely take an x away from everything. But can I divide all the numbers by something? I think I can divide them all by 3, right? So what I can do is I can factor it. I can divide everything by 3, all the numbers, all the coefficients. I can take away the x, 1x off of all of them, and I can see what I have left. Here, 3 divided by 3 would be 1. I don't need to put the 1. If I take away x to the third and I take away 1x, it's going to be x squared. Here, 6 divided by 3 is going to be 2. And if I take away one of the x's and take it out there, instead of having 2 x's, I only have 1. And here, minus 45 divided by 3 is 15. If I take an x and yank it away, I don't have any x's left. Okay, so I want to feel like I'm done here, but I'm really not. Because can't we factor this right here? Isn't this one we can do in our head, right? Do we know two numbers that multiply together to equal negative 15 that also add up to equal positive 2? All right, it could be negative 15 times 1, negative 5 times 3, negative 3 times 5, negative 1 times 15, right? Those are all the different ways to get negative 15. I think this combination right here, negative 3 and positive 5, would add up to positive 2. And so the best way, the most factored, the simplified way to write this is x plus 5, x minus 3, right? Those two numbers multiplied together to equal negative 15, positive 5 and negative 3. Positive 5 minus 3 would equal positive 2. And so this is actually my simplified version. I could put the g of x here if I wanted to, but it really doesn't matter. This is the simplified version of my function. And now that I have it factored, now I can look at, okay, what are my zeros? What are my x-intercepts? And all that, right? Right here. What number would I plug in to make this parentheses equal 0? That would be 0, right? 3 times 0 equals 0. What number would I put right here to make this parentheses equal 0? That would have to be negative 5, right? Because plus 5 actually means 5 to the left. And then here, whoops, my hand hit it and rubbed off some of the marker. Minus 3 actually means 3 to the right. Or another way of asking that is, hey, what number would you substitute right here for the x to make this parentheses equal 0? That would be positive 3. And so if I had my graph already drawn, which I didn't because I erased it, I could go to I'm just going to go to 5 for now. I'm sure I'm going to need more space. Okay, I've got my graph ready. I've got my zeros, which I said are at 0, right on the origin. At -5, 5 to the left. +3, which is 3 to the right. And now I'm ready to make my X and Y chart. I'm going to have to guess. I'm just going to put it down here so it doesn't run into anything. I need to pick a point in the middle here. I could pick more than one if I had a lot of time, but just to save time, let's just pick the easiest number, which I think is -1, for me anyway. I need to pick a point in between here, between these 2 points, in between these 2 zeros. I'm going to pick +1. And you know what? We'll just see how much time this video is if I need to pick some others. So now you just take -1 and you plug it in down here in the spot of the X. You could also plug it in up here, but that's just going to make it more complicated. If I put -1 right here, it would say, let's see, 3 times -1, that's -3. If I put -1 right here, -1 plus 5, that's 4. If I put -1 right here, -1 minus 3 is -4. Holy cow, look how crazy this one's going to be. That's +48. Do I really want to make my graph go to 48? Not really. If I put +1 in here, let me erase those because that one's done. If I put +1 right here, 3 times 1. If I put +1 right here, 1 plus 5, that's 6. If I put +1 right here, 1 minus 3, that's -2. And oh my goodness, look what we have now. -36. So this is another one that's going to go really crazy off my graph. This would be something like, I don't even know, something like this. +1 with -36 would be way off my graph. Something like this. You can see how these can get really crazy really fast. But I'm not so worried about the points over here going nuts. I was worried about, do you have the confidence to take a statement that's not factored and then break it down? See what they have in common. Factor out the greatest common factor. See what's left, and then your parentheses is usually going to be something you can factor as well, whether it's the one that you can do in your head, what numbers multiplied equal this, that add up to equal this, or if it's one of the ones that we saw like on the last one, something like this, where it's a difference of 2 squares, where you could say, oh yeah, that's x plus 4 and x minus 4, right? So, you know what? I had some more stuff planned for today, but I'm going to stop right there. I'm at 22 minutes. I will give you some questions today that are like this. We're just going to be looking at cubic functions, how we can graph them. And I hope this will help you be a little more confident, even though they don't really have anything to do with our Algebra 1 standards, I believe, in Missouri. It'll be fun just to know how to do them for the future. So thank you so much for watching. I'll put some questions on the Big Ideas Math, and I will catch you guys in the next one. See ya.